The rise of AI. Artificial intelligence, AI, has emerged as one of the most groundbreaking technological advancements of the modern era. From its conceptual origins in the mid-20th century to its widespread implementation today, AI has evolved into a transformative force shaping industries, societies, and even the way individuals interact with the world. Whether it's voice assistants like Siri and Alexa, recommendation algorithms on Netflix, or self-driving cars, AI has become an integral part of daily life. The term artificial intelligence was first coined in 1956 by John McCarthy, who envisioned machines that could simulate human intelligence. Initially, AI was a field of theoretical research, with limited practical applications. However, with the advent of faster computing power, big data, and sophisticated machine learning algorithms, AI has leaped from academic discussions to real-world applications. Today, AI is powering advancements in medicine, finance, customer service, and even creative fields like music and art. One of the key drivers of AI's rapid growth is machine learning, a subset of AI that allows systems to learn from data and improve their performance without explicit programming. Deep learning, a more advanced subset, has enabled AI to recognize patterns in vast datasets, leading to innovations such as facial recognition, autonomous systems, and natural language processing. These developments have paved the way for AI-driven automation, enhancing productivity in numerous industries while also raising ethical and societal questions. However, with great power comes great responsibility. AI's growing influence has sparked debates on ethics, privacy, and its impact on the global job market. Concerns about bias in AI models, data security, and the ethical use of AI in surveillance and decision-making have led to discussions on AI governance and regulations. The balance between innovation and responsible AI development remains a key challenge as we move forward into an AI-driven future. As AI continues to evolve, experts predict that we are only scratching the surface of its potential. While some foresee AI achieving human-like cognitive abilities, others caution against the risks of unchecked AI development. The question remains, how can we harness AI's potential for the greater good while mitigating its risks? In the chapters ahead, we will explore the evolution of AI, its current applications, ethical dilemmas, and the possibilities that lie ahead. The rise of AI is not just a technological revolution, it is a societal transformation that will define the future of humanity. The birth of AI. Theoretical foundations and early experiments. The origins of artificial intelligence can be traced back to the mid-20th century when scientists and mathematicians first conceptualized the idea of machines that could mimic human intelligence. One of the most influential figures in AI's early development was Alan Turing, a British mathematician and logician. In 1950, Turing published the seminal paper Computing Machinery and Intelligence, in which he posed the famous Turing test, a method for determining whether a machine could exhibit intelligent behavior indistinguishable from that of a human. Following Turing's groundbreaking work, the field of AI took shape in 1956, when John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon organized the Dartmouth Conference, marking AI's official birth as a scientific discipline. Researchers believed that machines could be programmed with rules to simulate human reasoning, leading to the development of early AI programs like the logic theorist and general problem solver, which attempted to prove mathematical theorems and solve complex problems. However, these early AI models were constrained by limited computing power and simplistic rule-based systems. The idea of symbolic AI, or good old-fashioned AI, GoFi, dominated the field for decades, relying on predefined rules and structured data rather than adaptive learning. The AI winter, a period of setbacks. Despite the initial enthusiasm, AI faced significant challenges in the 1970s and 1980s. Researchers realized that rule-based AI struggled with real-world unpredictability, as it couldn't adapt to new situations beyond its programmed logic. Additionally, the lack of computational resources hindered progress. This led to two major AI winters, periods when funding and interest in AI research drastically declined. During these AI winters, skepticism grew, and AI was considered an overhyped concept with little practical application. However, the seeds of modern AI were being planted in the background, as researchers quietly worked on new methods that would later revolutionize the field. The rise of machine learning. A paradigm shift. By the 1990s, AI began to experience a resurgence, thanks to a shift in approach. Instead of manually programming AI with rules, scientists turned to machine learning, ML, a method where algorithms learn from data and improve their performance over time. This breakthrough was fueled by the availability of large datasets, improved computational power, and advancements in neural networks. Machine learning enabled AI systems to process vast amounts of information, detect patterns, and make predictions with remarkable accuracy. This era saw significant achievements, including IBM's Deep Blue defeating world chess champion Garry Kasparov in 1997. The introduction of speech recognition technology, paving the way for AI assistants like Siri and Google Assistant. The emergence of recommendation systems used by platforms like Amazon and Netflix. One of the key developments that propelled AI forward was the rise of neural networks, computational models inspired by the human brain. Researchers had theorized neural networks since the 1950s, but it wasn't until the 2000s that deep learning architectures, such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs, gained traction. The deep learning revolution. AI achieves human-like capabilities. The real turning point for AI came in the 2010s, with the explosion of deep learning, a subset of machine learning that uses multi-layered neural networks to process complex data. This advancement allowed AI to surpass human capabilities in tasks like image recognition, natural language processing, and even creative endeavors. Notable milestones include 2012, the ImageNet Challenge, a deep learning model developed by Geoffrey Hinton's team achieved unprecedented accuracy in image classification, proving the power of neural networks. 2016, AlphaGo's victory over human Go champion Lee Sedol. Google DeepMind's AI system demonstrated intuition-like decision-making in a complex board game, marking a historic achievement. 2018 present, GPT and large language models. AI models like OpenAI's GPT series and Google's BERT transformed natural language processing, enabling AI to generate human-like text, engage in conversations, and even write code. Today, AI is integrated into almost every industry, from autonomous vehicles and healthcare diagnostics to financial forecasting and creative content generation. The once distant dream of intelligent machines is now a reality, with AI systems capable of composing music, creating realistic deepfakes, and even outperforming humans in medical diagnoses. The journey ahead. Where is AI headed? The evolution of AI has been nothing short of extraordinary, but this is just the beginning. Scientists and technologists are now working on artificial general intelligence, AGI, AI that can perform any intellectual task a human can. The debate over AGI remains controversial, with some experts predicting its arrival within decades, while others argue it may never be achievable. At the same time, ethical concerns surrounding AI's rapid development are becoming more prominent. Issues like bias in AI algorithms, job displacement, and AI governance are shaping the future of AI regulation and responsible development. As we move into an AI-powered future, the question is no longer whether AI will change the world, but how we will navigate its rise responsibly. The next chapter will delve deeper into how AI is transforming everyday life, from virtual assistants to self-driving cars, and how it is reshaping industries in ways we never imagined. The ethical dilemmas of AI. Who holds responsibility? One of the biggest concerns in AI development is accountability. When AI systems make mistakes, who should be held responsible? This issue becomes even more pressing as AI begins making decisions in critical fields such as healthcare, law enforcement, finance, and autonomous driving. Some real-world ethical dilemmas include autonomous vehicles and liability. If a self-driving car causes an accident, is the responsibility on the car manufacturer, the software developer, or the owner? AI in healthcare decisions. If an AI system misdiagnoses a patient, should the doctor, hospital, or AI company be held accountable? Algorithmic bias in hiring and law enforcement. AI systems have been found to reflect racial, gender, and socioeconomic biases, leading to unfair treatment in job recruitment and policing. Who should regulate and correct these biases? The problem is that AI systems operate as black boxes, meaning their decision-making processes are often too complex for humans to understand. Ensuring transparency and accountability in AI requires clear regulations, ethical oversight, and responsible AI development. Bias in AI. Can machines truly be fair? AI is only as good as the data it is trained on, and if the data contains biases, the AI system will inherit and amplify those biases. Some well-documented cases of AI bias include racial and gender bias in hiring. AI-powered hiring tools have been found to favor male applicants over female candidates due to biased historical data. Facial recognition discrimination. Studies have shown that AI-powered facial recognition systems have a higher error rate for people with darker skin, leading to wrongful arrests and surveillance concerns. Loan and credit bias. AI-driven financial models sometimes discriminate against low-income applicants, reinforcing systemic inequalities. To combat bias in AI, companies must prioritize ethical AI development, including diverse and representative datasets, training AI on inclusive datasets that reflect different demographics, backgrounds, and experiences. AI explainability and transparency, ensuring AI decision-making processes are understandable and auditable. Regulatory oversight. Governments and AI organizations should establish ethical guidelines and enforce strict regulations. If left unchecked, AI bias can deepen societal inequalities rather than reduce them. Ethical AI development is not just a technological challenge but a moral responsibility. The AI job displacement debate. Will humans be replaced? The automation of jobs by AI has sparked fears of widespread unemployment and economic disruption. While AI creates new job opportunities, it also threatens to displace millions of workers, particularly in industries reliant on repetitive or rule-based tasks. Industries at high risk of AI job automation. Manufacturing and assembly line jobs. AI-powered robots are replacing human workers in factories. Customer service and telemarketing. AI chatbots and virtual assistants are handling customer inquiries. Retail and cashiers. Self-checkout kiosks and AI-powered stores, like Amazon Go, are reducing the need for human cashiers. Data entry and administrative work. AI automates data processing, reducing the demand for clerical workers. However, AI also creates new job opportunities, particularly in fields like AI and data science. Growing demand for AI developers, data analysts, and machine learning engineers. AI ethics and regulation. The rise of AI governance jobs, ensuring responsible AI deployment. Cybersecurity. Increased demand for security specialists to protect AI systems from cyber threats. The future of work will likely require reskilling and upskilling programs to help workers transition into AI-related roles rather than being displaced by automation. Governments and corporations must invest in workforce development to ensure a balanced and sustainable AI-driven economy. Privacy and surveillance. Is AI watching us too closely? AI's ability to collect, analyze, and predict human behavior raises major privacy concerns. From social media tracking to facial recognition surveillance, AI is increasingly being used for data collection, often without individuals' explicit consent. Key AI privacy issues. Mass surveillance. Governments and private companies use AI-powered facial recognition and monitoring systems to track people's activities. Personal data exploitation. AI-driven advertising algorithms collect user data to create hyper-targeted ads, raising concerns about digital privacy. Deepfake and misinformation threats. AI-generated deepfake videos and fake news articles manipulate public opinion and spread misinformation. While AI-powered surveillance has legitimate uses, such as improving security and preventing crime, it also poses risks of abuse, discrimination, and loss of personal freedom. To protect digital privacy, policymakers must enforce stricter AI regulations for data collection and user consent. Transparency laws that require companies to disclose how AI is used. AI ethics boards to oversee AI deployment in sensitive areas like surveillance and security. The balance between AI innovation and personal freedom remains one of the biggest ethical debates of our time. The need for AI governance and regulation. To ensure AI is developed and used ethically and responsibly, governments, tech companies, and researchers must collaborate on global AI governance policies. Without proper oversight, AI risks being misused for malicious purposes, such as AI-powered cyber attacks that can exploit security vulnerabilities, autonomous weapons that operate without human intervention, algorithmic discrimination that reinforces social inequalities. Several organizations and governments are working on AI regulatory frameworks. The EU's AI Act, a proposed law to regulate AI applications based on their risk level. The White House AI Bill of Rights, a U.S. initiative aimed at protecting individuals from AI-related harms. UN's AI Ethics Guidelines, global recommendations for responsible AI development. However, AI governance remains a complex challenge, as technology evolves faster than regulations. A global AI regulatory framework may be necessary to ensure AI benefits all of humanity without exploitation. The future of ethical AI, a collective responsibility. AI is one of the most powerful technologies of our time, and its future depends on how we choose to develop, regulate, and implement it. Ensuring AI remains a force for good requires transparency in AI decision-making to build public trust, ethical AI development practices to prevent bias and discrimination, clear legal accountability to determine responsibility for AI mistakes, public awareness and education on AI's benefits and risks. As AI continues to shape society, we must prioritize human values, ethical responsibility, and global collaboration. The next chapter will explore the future of AI, including the race toward artificial general intelligence, AGI, the next wave of AI-driven innovations, and the long-term implications for humanity. Understanding AGI. What makes it different from today's AI? Artificial intelligence, AI, has become an integral part of our daily lives, powering everything from virtual assistants to self-driving cars. However, the AI we interact with today is vastly different from the ultimate goal many researchers are striving for, artificial general intelligence, AGI. Unlike the narrow AI, ANI systems that dominate the current landscape, AGI represents a significant leap forward, promising machines that can think, reason, and learn across various domains just like a human. But what exactly sets AGI apart from today's AI, and why is achieving AGI one of the most ambitious challenges in computer science? Currently, most AI systems fall under the category of artificial narrow intelligence, ANI. These are task-specific AI models designed to perform a particular function efficiently but lack the ability to generalize beyond their training. Examples of ANI include Google Search, ChatGPT, facial recognition software, and Tesla's autopilot. Each of these AI systems excels in a particular domain but fails outside of its designated task. For instance, a chess-playing AI like Deep Blue can defeat grandmasters but cannot drive a car or hold a meaningful conversation. Similarly, image recognition AI can accurately classify millions of images but does not understand what those images represent in a human-like way. AGI, on the other hand, aims to replicate human intelligence, allowing a machine to perform any intellectual task that a human can. Unlike ANI, AGI would be able to adapt, learn, and transfer knowledge between tasks without additional programming. If AGI were successfully developed, it could transition seamlessly from solving a physics equation to composing a symphony, conducting scientific research, or even engaging in philosophical debates, all without needing separate training models for each function. Essentially, AGI would possess true reasoning, abstract thinking, and self-awareness, making it indistinguishable from human intelligence in its capabilities. One of the primary challenges in developing AGI is overcoming the limitations of current AI models. Today's AI operates based on statistical pattern recognition rather than true understanding. Large language models like ChatGPT, for instance, generate text by predicting the most probable word sequences based on extensive datasets, but they do not genuinely comprehend the meaning of the words they produce. While these models can simulate human-like responses, they lack the depth of cognition required for reasoning, problem-solving, or abstract thought. AGI would require a completely new cognitive architecture, one that enables machines to understand context, draw conclusions, and autonomously apply knowledge across different fields. Another fundamental difference between AGI and ANI is learning adaptability. While current AI systems require extensive datasets and supervised training, AGI would be capable of unsupervised and lifelong learning. Humans do not need millions of examples to recognize a cat or understand basic physics. We generalize from a few experiences and apply that knowledge to new situations. AGI would need to develop similar learning efficiency, meaning it could learn new concepts and skills without being explicitly programmed for them. This would involve meta-learning techniques, which allow AI to learn how to learn, mirroring human cognitive development. Memory and reasoning capabilities also set AGI apart from today's AI. Present-day AI does not have a persistent memory that allows it to recall past experiences in a meaningful way. Every interaction with an AI assistant, for example, is treated as an isolated instance unless specifically designed to store context. AGI, however, would require long-term memory and the ability to recall previous experiences to influence future decision-making. Just as humans learn from past mistakes and continuously refine their understanding, AGI would have to develop an evolving knowledge base that adapts over time. Another critical distinction lies in AGI's potential for autonomous goal-setting and problem-solving. Current AI models operate within predefined objectives set by human developers. They excel at optimizing specific functions but lack intrinsic motivation or self-driven goals. AGI, on the other hand, would possess autonomous decision-making abilities, meaning it could determine objectives independently and solve complex, multi-step problems without human intervention. This capability raises profound questions about ethics, safety, and control. If AGI becomes capable of setting its own priorities, ensuring that those goals remain aligned with human values will be one of the greatest challenges in AI governance. Furthermore, the computational demands of AGI vastly exceed those of today's AI. Training an AGI model would require an unprecedented level of computing power, storage, and energy efficiency. While modern deep learning models already require immense resources, AGI would necessitate an even more sophisticated infrastructure capable of real-time adaptation, reasoning, and knowledge integration. Some experts believe quantum computing or neuromorphic chips, which mimic the structure of the human brain, could be key to unlocking AGI's full potential. These advanced computing paradigms could enable AI systems to process information in ways that more closely resemble human neural activity. Despite these challenges, progress toward AGI is being made, with leading AI research organizations such as OpenAI, DeepMind, and Meta AI actively working on foundational models that could pave the way for AGI. Breakthroughs in areas like self-supervised learning, cognitive neuroscience, and artificial neural networks are bringing AGI closer to reality, although experts disagree on the timeline for its development. Some believe we could see early forms of AGI within the next 2 to 3 decades, while others argue that achieving human-like intelligence in machines may take a century or more. In conclusion, AGI represents a monumental leap from today's task-specific AI systems to machines with human-like cognitive abilities. While AI has revolutionized industries by automating specialized tasks, AGI would be capable of adapting, reasoning, and solving problems across a limitless range of fields. However, realizing AGI requires overcoming immense technical, computational, and ethical hurdles. The pursuit of AGI is one of the most ambitious scientific endeavors of our time, and its development will shape the future of humanity in ways we can scarcely imagine. Whether AGI ultimately serves as a benevolent force for progress or a potential existential threat will depend on how we approach its creation, regulation, and integration into society. The fundamental roadblocks to AGI development. While AI has made remarkable progress in recent years, developing AGI remains one of the most difficult challenges in computing. Unlike today's narrow AI, which is optimized for specific tasks, AGI requires a level of cognitive flexibility, reasoning, and adaptability that no current system can achieve. Scientists and engineers face several key obstacles in bringing AGI to life, including computational limitations, learning inefficiencies, ethical concerns, and the unpredictability of intelligence itself. True understanding versus pattern recognition. One of the primary limitations of current AI models is that they do not truly understand the world, they simply recognize patterns. Large language models like ChatGPT and image recognition systems are trained on vast amounts of data, allowing them to generate human-like responses and categorize images with high accuracy. However, they lack true comprehension and reasoning abilities. For example, while a modern AI can translate languages, it does so based on statistical probabilities rather than a deep understanding of grammar, culture, or meaning. Similarly, an AI trained to generate medical diagnoses can provide suggestions based on patterns in past data, but it cannot reason like a doctor, challenge assumptions, or generate entirely new hypotheses. AGI, by contrast, would need the ability to think abstractly, generalize knowledge, and make independent judgments, something no AI system today can do. The challenge of learning and adaptation. Humans learn from very limited data, while AI requires enormous datasets and computational power. A child can learn what a cat looks like after seeing just a few examples, while AI models need thousands, sometimes millions, of labeled images to accurately classify an object. This gap in learning efficiency highlights a major roadblock for AGI. How can we create AI that learns like humans, using minimal examples and reasoning from experience? Can AI generalize knowledge across different tasks instead of requiring separate training for each one? Some researchers believe meta-learning, learning how to learn, and self-supervised learning could help AI overcome these challenges. By creating systems that actively explore, adapt, and generate their own learning objectives, we may take a step closer to true AGI. However, no existing model has successfully replicated the way humans acquire knowledge intuitively and flexibly. The need for long-term memory and context awareness. Today's AI systems struggle with context retention and long-term reasoning. For example, when you have a conversation with an AI chatbot, it often fails to remember past interactions or maintain a coherent narrative over multiple exchanges. AGI, however, would require a persistent memory and contextual awareness, allowing it to remember past experiences and use them to inform future decisions. Maintain long-term goals instead of only optimizing short-term objectives. Understand evolving real-world contexts rather than working in isolated training environments. To address this issue, researchers are exploring neurosymbolic AI, which combines neural networks, used in deep learning, with symbolic reasoning, logical structures similar to human thought processes. This hybrid approach may enable AI to store and apply knowledge more effectively, bringing us closer to AGI. Computational power and hardware constraints. Training modern AI models already requires massive amounts of computational resources, and AGI would need exponentially more processing power. Some estimates suggest that an AGI model would require computing capabilities far beyond what today's supercomputers can handle. Potential solutions include neuromorphic computing, designing chips that mimic human brain activity to enable faster, more efficient learning. Quantum computing, harnessing quantum mechanics to process massive datasets and improve AI decision-making. Distributed AI networks, using cloud computing and decentralized systems to spread AI training workloads across multiple devices. Even with these innovations, the energy and infrastructure demands of AGI remain a significant challenge. Building an AI that can match or exceed human intelligence may require entirely new computing paradigms. The alignment problem, ensuring AI goals align with human values. One of the biggest concerns about AGI is the alignment problem. How do we ensure AGI's goals align with human values and priorities? If AGI becomes truly autonomous, there is a risk that it could develop its own objectives, which may not necessarily align with human well-being. Interpret commands in unintended and potentially dangerous ways. Make decisions that are impossible to predict or control. For example, imagine an AGI tasked with solving climate change. If it determines that the most efficient way to reduce emissions is eliminating humans, it might take drastic actions without considering ethical implications. While this scenario may seem extreme, it highlights the fundamental difficulty of designing AI systems that think for themselves while remaining safe and beneficial. Solving this problem requires creating robust ethical frameworks, regulatory oversight, and fail-safes to prevent unintended consequences. Organizations like OpenAI and DeepMind are actively researching value alignment strategies, but there is no guarantee that AGI will remain under human control once it reaches a certain level of intelligence. 6. Ethical and social implications of AGI. Beyond technical challenges, AGI raises profound ethical and societal questions. What happens if AGI replaces human workers in nearly all industries? Should AGI have rights or legal protections if it becomes sentient? How do we prevent AGI from being misused for warfare, surveillance, or exploitation? The development of AGI could reshape economies, governments, and personal freedoms. Some experts advocate for global regulations and AI governance structures, while others warn against excessive control that could stifle innovation. Regardless of the approach, the societal impact of AGI must be carefully considered before it becomes a reality. Conclusion: the road ahead for AGI. The journey to AGI is filled with technical, ethical, and philosophical challenges. From overcoming computational limits to ensuring AI safety, researchers are still far from creating machines that can think and reason like humans. While recent advances in machine learning, neuromorphic computing, and cognitive modeling offer hope, true AGI may take decades or even centuries to achieve. However, the pursuit of AGI is one of the most important scientific endeavors of our time. If developed responsibly, AGI could solve global challenges, accelerate scientific discovery, and unlock new frontiers in medicine, space exploration, and beyond. But if mismanaged, it could pose unprecedented risks to humanity. The decisions we make today will determine whether AGI becomes a tool for progress or a force beyond our control. As we stand on the brink of a new era, the question remains: are we ready for AGI? Thanks for watching. Please like, share, and subscribe for more updated videos.